Okay, Assalamualaikum. Alright, now let's look at the example on topic two-dimensional vectors. Alright, so we have here the first example. Given a point A, 3, 4 and the origin O, okay, then find the position vector of OA, the unit vector in the direction of A, and the direction of vector 3, 4. Okay, so firstly, the given information is we have a point A is 3, 4. So when you have a point A, given a point A, you need to consider first the position vector of A from the origin. Alright, that is OA. Okay, so for A, firstly the position vector of OA, it will be either you want to write in the form of ij, that is 3i plus 4j, or you can write in the form of row matrix 3, 4, or some books you can also write in the form of column matrix 3, 4. So we have three types of notation that we can use to represent the vector. Okay, alright, and then B. Alright, for B, find the unit vector in the direction of A. Okay, meaning you want to find the unit vector of OA. Okay, so the formula for the unit vector is so now you have OA, so it is OA, vector of OA, divided by magnitude of OA. Okay, alright, so let's say we want to use this one. Okay, we want to write in the form of horizontal matrix. Okay, so now we will have your OA is 3, 4. Okay, so divide by the magnitude will be the square root of x square, which is 3 square plus 4 square. Okay, so now we will have it is 3, 4 divide by 5. Okay, but this is not your final answer. Your final answer must be in the form of x and y. So you must write it as 3 over 5, 4 over 5. Okay, or you can also write in the form of ij, 3 over 5i plus 4 over 5j. Okay, so this is your unit vector. Alright, so next we want to find the direction of vector 3, 4. Okay, so direction angle, the formula that we will use is involving the tangent, right? So firstly we need to draw. Okay, we have 3, 4. Okay, so if we draw, the 3, 4 is in the first quadrant, so we can just write like this. So 3, 4, let's say this one. Okay, 3, 4. Okay, so your theta or the angle is the angle between the vectors. So this is your vector OA, right? And the positive x-axis. So this is positive x-axis. Okay, alright, then how to find the formula? Okay, so this will be your B, this will be your A, and the formula is tangent theta equals to B over A, right? Which means your B is y, so it is 4 over your A is 3. Okay, that is tangent theta. So what is your theta? Your theta is the tangent inverse of 4 over 3. Okay, so if you calculate, you will get 53.13 degrees. Or if you want to write in the form of radian, you have to multiply with pi over 180 degrees and you will get 0.9273 radian. So this is the answer for C. Okay, let's look at second example for the two-dimensional vectors. Okay, we have here, find the magnitude of the vector AB from the point A, -3, 5, to the point B, 7, 9. Then find the unit vector and angle between AB and the x-axis. Alright, so now you have here is 2 points. So we have 2 points, A and B. Okay, since you have 2 points, meaning you have to consider a vector A and from the origin and another vector B from the origin. Alright, position vector B from the origin. Alright, okay, so we have here is, okay, for the solution, firstly we have your OA is, consider OA is -3 and 5, and your OB is 7 and 9. Alright, okay, and then you want to find the magnitude of vector AB, meaning you have to find first what is your vector AB. Alright, so to find the vector AB, so AB, the formula is, okay, the formula is AO plus OB. Okay, this is your original formula, but then we have simplified the formula. Okay, where the last formula we have simplified is, so this one we have -OA plus OB, and lastly we have OB minus OA. Okay, so we have simplified the formula of AB, that is, it is terminal minus initial. Right, so A is your initial and B is your terminal. Okay, so this is the formula that we have discussed before this. Alright, so now what will be your AB? So now you will get your AB will be, okay, so OB, the terminal, which means you have 7 and 9, minus with -3, 5. Okay, so when you simplify the operation, so we have here for x it will be 7 minus -3, and then 9 minus 5 for y. So we have it is 10 and 4. So this is your AB. AB is 10, 4. Then we need to find the magnitude, right? So magnitude of AB will be, and when you find the magnitude of AB, it will be the square root of x square. So your x square is 10 square plus 4 square. Okay, so it will be square root of 116. Okay, you can also simplify your square root. Okay, meaning you have to find a perfect square. For example, let's say we want to find 4. So let's say 116 is equals to 4 times width. So 116 divided by 4, you will get it is 29. It is equals to 4 and 29. Right? So you can simplify as square root 4 times 29. Okay, since 4, you can square root your 4. So it will be square root of 4 is 2. Okay, or if you write it one by one, it will be square root of 4 times square root of 29. So you will get it is 2 square root 29. So this is how you simplify your square root. Firstly, you have to find a perfect square. So what is the number of perfect square? 4, 9, 16, 25. Okay, and then if you can simplify, then you have to simplify your square root. Okay, all right, so this is the answer for your magnitude of AB. Okay, next we want to find the unit vector. This one, unit vector. All right, okay, now to find the unit vector, okay, so unit vector u hat equals to, the formula now will be vector AB divided by magnitude of AB. Okay, then it will be, what is your vector AB? It is 10 and 4. 10, 4 divided by, the magnitude is 2 square root 29. So meaning you have to separate for each x and y. So 10 over 2 square root 29, 4 over 2 square root 29. So this is why we need to simplify your square root, because basically you can simplify it for another things that we want to find. Let's say for here we have unit vector. So when you simplify, you will have here, it is 5 over set 29 and 2 over set 29. Okay, so this is for unit vector. And another one, we want to find the angle between AB and the x-axis. Okay, so for the angle, to find the angle for two-dimensional vectors, firstly you need to draw. So let's say here we have here is 10 and 4. Okay, this is your AB. Okay, all right, then your theta will be the angle between the vectors and the positive x-axis, right? Okay, so your B here and your A is here. Okay, so what will be your theta? The formula that we will use is tangent theta equals to B over A. Okay, opposite over the adjacent. So we have here your B is 10 and your A is, your B is 4, is for Y, and your A is x, 10. Which means you have tangent theta is 2 over 5. So what will be your theta? Your theta will be the inverse tangent of 2 over 5. Then when you calculate, you will get it is 21.8 degrees. Or if you want to write in the form of radian, then you will get 0.3805. Okay, so this is the answer for the angle between the vectors AB and the positive x-axis. All right, okay, so these are two examples that we have in two-dimensional vectors. So later on we will see another other examples for three-dimensional vectors. All right, okay, thank you.